for an operator, it's probably easy to predict if there is a process that depends on one variable. But often processes don't depend on just one variable. They're multidimensional processes, and they're fairly complex processes and non-linear systems that you can not so easily understand how it works. So in these systems, it could really find how the process works and do all the load for you.
Hello everyone and welcome to the Unofficial Ignition podcast. My name is Jonas and today we are talking about machine learning. I'm here with Ivana.
Hello.
You have recently become part of the Inuda team.
Yes.
And how did you encounter machine learning for the first time? Why did you get interested in it?
Okay, so I'm working in the field of mechatronics, which is a general field. We are dealing with industrial automation and all kinds of things. And in the latest years, there has been an increasing trend of machine learning applications all around us. Like you can see in applications like Google Translate or, I don't know, Facebook image recognition, face recognition, and a lot of applications out there, recommendations on Amazon or Netflix or on any other of the popular websites using machine learning. And you see it achieving incredible results. And
just using Google Translate like 5 years ago was garbage, right?
Yeah, like
Now
especially for some rare languages, like for Serbian, which is my native language, Google Translate was really terrible. Like you would put some sentence in English and it would translate every word by word and give you a garbage text. But now it has really improved with all these machine learning improvements, and through learning, through time, it has really become a very good translator, which you can actually use for some smaller portions of text.
I was in Italy last month and just speaking with my taxi driver through Google Translate, where he didn't know a word English, and I was just talking English to my phone and that was speaking Italian to him, and then he was speaking Italian to the phone and translating it seamlessly. It was amazing, like a really good experience with someone that we had no common language at all.
Yeah, so for example, here you don't have just the translation part, you have the language acquisition, recognition, the natural language processing part, which takes your words. You don't have to type it in. It takes your words, it translates it into text, and then it translates the text into the required language, which is
like
really
layers and layers.
different machine learning applications. So generally we see a rise in machine learning applications in various fields and in many common applications that we see every day. So I think it's natural to wonder if we can apply it for what we really do. For example, for me, it is in industrial automation. Like, can we use it in some useful way to help to help people to gain more value, to get better processes? And how can we do it, and how can we implement it?
So how does it actually work when you type in something to Google Translate? Like, what happens? Another person isn't translating it, so how does this machine know what to do, and why has it gotten so much better the past few years?
First, I will answer the second question. Why has it gotten so much better in the past few years? Like, machine learning, it has been around for decades, and a lot of models in machine learning and algorithms have been developed, and theoretically they existed, and some were implemented with more or less success. But why did it become so popular in the recent years? There are several answers to that. One of those is the amount of data that is available. Like today we are talking about big data, thousands, millions, billions of instances of data, of examples that we can use to train these models. The second thing is the computational power that has risen, that the machines have gotten just faster with better processors, and there has been a development toward using GPUs, graphical processing units, and more recently TPUs, tensor processing units, which can perform very fast mathematical operations with, especially with matrices that are used in machine learning models, and so by using these special hardwares, you can increase the speed of training a model multiple times. So something that was like 20 years ago, it would need much more time to train such a model and to use it at all. Now it's more available, it's more achievable with the current hardware that exists. And the third thing is the rise of the new algorithms, especially deep learning algorithms, which are they are like neural networks that are enhanced with new architectures that are specifically good for some specific types of data, like for example for images, which are two-dimensional data, and for time series analysis, such as the text recognition and text translation, which is a sequence of words coming one after another in a specific order.
Okay, cool. And so if we should take a step back and ask the question, what is machine learning? Like, what's actually happening? Well, it's so usually you like 2 + 2 is 4. I guess it's a different mechanism than just calculating, or is it?
Well, actually, machine models generally are calculating something. So, what is a machine learning model? Why is it different than like normal calculation? 2 + 2 = 4.
Right.
In normal calculations, we as humans or engineers who are designing the algorithm, we are the ones who give it the parameters. We are the ones who know the model of the process that we are modeling, and we build the equations by ourselves. Maybe we need to find some parameters in the process, but we are the ones who know how the model works, how the process works, and how to build a model for this process.
Right.
Whereas in machine learning modeling, we have some general models like, simple ones like linear and logistic regression. We have, support vector machines. We have neural networks and lots of different types of models that are in nature, they are general models. For example, a neural network, it has inputs, it has some neurons, some structure, and it has some outputs. So you give it some inputs and try to achieve the expected outputs. How does it achieve these outputs? You don't program it. You just tell it, okay, you will have this and this number of neurons, this and this number of layers, you will have this architecture, but you need to learn the parameters of the model yourself.
Okay.
So this model, we can take it as a black box, like let's say it's a neural network, but it can be something else as well. We would train it through time with some samples. We have examples of data from the past, which we know what outputs they were giving. And we would give those inputs with their outputs to the model.
Right.
And the model will try to adjust the parameters in a certain way, which is also a defined way. It will try to learn these parameters to reach the outputs that are real outputs from the model.
That we have
and
in
that
the data set.
We gave it in the data set.
Right.
So for the first time, of course, it will make a big error. So then this error, it will try to put it back and somehow adjust the parameters to next time make less error.
Right.
So we have some realistic error measures. How we can measure, is it a good match or it's really, really wrong? And it will try to lower this gap, to lower the error and to get as good results as possible on the training data set. So the training data set is usually a historical data set of the past states, which we know what had as an output.
And then when you get close, when the algorithm gets close, you know you have a good, you have a good algorithm, or is it a good neural network, or what's good when it's done?
Okay, so when it's done, the model has good parameters.
Okay.
So we can say that the model has been trained and now it has learned its parameters.
Right.
So when we train it on this training data set, we usually want to test it on some new data. So basically, when we start training the model, we would usually take some amount of the data from the training data set to make like a test set, which we will use in the end of the training process to put again to the model, which are now like some new samples for it. It are the samples it didn't use during the learning phase, during the training phase, and it will try on these new samples to predict the output. And again, we still have the outputs. We know what are the results of the process. So we will try to match them and again see what is the error on these unseen samples, on these new samples. So in fact, we will first train on the training data set, then see the results on the test data set. If it's not close, not as good as it should be, then we would probably try to adjust the model, maybe change the model, try another candidate model. Maybe for this problem, another model would be much better. And so it's a process of trying and searching for the best solution.
Cool. And then in the context of Ignition, what's possible in that environment? What can you actually do in terms of machine learning through the Ignition platform?
Yeah, so we have this machine learning community which has developed through the years and which offers really great models and great opportunities to be applied in any kind of process, any kind of problem. And we have usually SCADA systems like the ones made with Ignition, which are usually monitoring and controlling the process on some local level. And often these systems don't include additional functionalities like machine learning and analysis of data.
In traditional SCADA systems.
In traditional SCADA systems, yes. And of course in modern SCADA systems and in the context of Industry 4.0, where everything is getting interconnected, even in production, in industry, and lots of data are again getting acquired and stored, we can probably look into this direction, like why wouldn't we use machine learning in a SCADA system?
Because we have all this data.
We have all this data. Super good. We can have additional computing power, which is required for machine learning. We have processes to model. We have available models. So, why don't we try it?
Why not? Yeah.
And so if we look into Ignition, which is a really cool platform for SCADA, they offer also some possibilities for machine learning. At the moment, these possibilities are kind of limited, but still they exist. And starting from Ignition 7.9 point something, they introduced the possibility of using Apache Math libraries, which include some of the machine learning models.
Okay.
It's not a big
full set of.
It's not a full set of machine learning models, but you can use like some simple models like linear regression or polynomial regression or neural networks in some simpler form. And you can use like some clustering algorithms like k-means plus and db-scan algorithm and so on. So you do have a set of machine learning models that are available within Ignition. And this is a huge deal because so far it was not possible at all. Like if you would want to code a machine learning model in any SCADA system so far, you would in a traditional SCADA system, you would need to code it from scratch. And basically, it's just not feasible.
Yeah.
Like to make a machine learning framework and machine learning libraries, engineers are working for years in teams and in the community
with
where they
researchers and probably
researchers and those who are applying it and they are seeing that this could be done better in this way or in this way and optimizing the algorithms and the models. And so in the end you have a model that works faster, better and just performs better. And if you want to do it from scratch, probably you can do it as well, but it will not be as good as it is, and it will take you an enormous amount of time and effort to do it.
So you can take your existing data from the SCADA system, Ignition in this case, and then put it into your machine learning framework.
Yes.
Is that how it could work in Ignition?
Yeah, it's also a kind of a way how it could be done. Like you could export your data, especially in Ignition, which is connected to a SQL database. So you could easily access this data from another system, for example. And you could push your data there. You can use another machine learning framework to train a model and to predict something and then push this data back to Ignition. So it's one way to do it. But again, it's a more complicated way to do it. So you see, if you have these machine learning models and capabilities in Ignition inside, it's I think it is much easier for the end user to accept it. Like, okay, I don't need anything else. It will be added in my existing environment. I don't have to buy additional thing. I don't have to give my data to an external server or anything. Like it all happens on the local level, and it gives also gives a kind of security to the people involved in the process.
Cool. What would just for the sake of me understanding it better, what would a simple example of machine learning in an Ignition, like in a SCADA system, what would that look like? Like you have a lot of people who sits in control rooms and look at all this SCADA data.
How could machine learning help them?
What's in it for them? Like how?
Okay, so for example, let's say you have a simple process that can be approximated with a line. For example, for this you can use a linear regression model, which is like one of the simplest models. It's basically fitting a line to the data points in space. So maybe you have such a process and you can model it in Ignition, and so you get the line, the trend line of this data, how it should work through time.
Yeah.
And
how it should behave.
How the process behaves through time.
Right.
And so based on this the prediction, you can predict a data point in the future. So you can say, for example, you have a tank which is filling, and you want to know when it will reach a certain level. Right. So it's filling on a constant speed, or approximately. So you get some data points when it reaches this level, and you take a linear regression. It will predict the line of the process, how it's behaving.
Right.
And it can tell you, for example, your full level will be reached in 2 days. So for you as an operator, how it can help you. For example, if you have just this one tank and you watch it on a screen, of course you can probably see by yourself that it's reaching this point.
I'll come back in 2 days.
Yeah, and I see that approximately it will happen about 2 days, especially if you're an experienced operator who knows a lot about this system, about this process. You will easily know that it's going to happen. But what if you have a much bigger system with, for example, 2,000 or 3,000 of such tanks? So you should, if you want to see this, where they are, how they are standing, you should probably check each one of those, like where is it, how fast it is filling. Maybe they are not all filling with the same speed, and you would have to check each one of those to see, hey, where do I need to pay attention next? And with this machine learning, it could automatically detect all this for you.
Right.
I mean, this is really a simple model, but
sure.
It's something to illustrate it, like how it could help that.
So it could be a big help in predicting when actions needed to be taken in certain systems.
Yes, and also it can, of course, there are much more complex machine learning models which can predict more complex things.
Right.
Like it's for an operator, it's probably easy to predict if there is a process that depends on one variable and which can be graphically visualized. For example, in this process, probably you can see through time how the tank is filling. So it's something that you can easily visualize and easily see. But often processes don't depend on just one variable. There are multidimensional processes, and they're fairly complex processes and non-linear systems that you can not so easily understand how it works. So in these systems, it could really find these laws, how it works, how the process works, and do all the load for you.
Right. Cool. And that is, I guess, when you get more and more complex, you at some point get out of the boundaries of what you can do in Ignition now.
Yes.
What do you see the next step in SCADA systems as a whole, and specifically in Ignition? Like what do you think they should do now?
Okay, so I would just add that there are other options for using Ignition and machine learning.
Okay.
For example, they have a partner which is developing connections from Ignition to the cloud-based machine learning services. For example, AWS or Microsoft Azure cloud services and Google cloud services. So you can easily put it as a module in Ignition and use it as is, and just connect your data from your Ignition system to this cloud service. Use it as it is a service. You can develop any kind of machine learning model there, train it, and just push it back to Ignition.
Right.
And this is all very cool, but on the other hand, this way you are kind of exposing your data outside of the system. So whenever you are using a cloud service, your data is no longer your own. Right. I mean, of course, they are very secure systems, and they really pay attention to this, that this is your data and they can guarantee you and all. But for some people, just it's not they don't want to do it. It's not enough.
Yeah.
So that's why they really want to do it on a local level.
Okay.
So Ignition offers also other kinds of possibilities. You can also build your own models for machine learning in Ignition, where you can probably use some of the libraries or of the frameworks for machine learning that already exist. Since Ignition scripting is based on Jython, it is basically Python based on Java. And you can most easily implement some Java libraries. There are some Java machine learning libraries, and probably they can be more easily integrated into Ignition than other types. But also you can use more general frameworks that are, for example, a lot of them are developed in C Python, which is something we normally know as Python. It is based on C, a C programming language. And this kind of framework or libraries cannot be directly imported in Jython. That is the unfortunate thing about Ignition, that it uses Jython, and we can't use a lot of C-based Python libraries that exist.
Right, which is what you ultimately want.
Which is what machine learning engineers would definitely want seeing there, because this gives you enormous possibilities. Like in Python, in this, let's say, normal Python, you have a lot of already developed libraries and frameworks that you can use, and starting from, I don't know, NumPy, which is like the basic library that you would use in Python, you can't use it in Jython because it is C-based.
Okay.
And
so we're still a long way away in Ignition, but the first step has been taken.
Yes.
And you can build something.
Yes.
And I guess that's a good starting point. And it's within the closed system, which I guess is the most important thing for a lot of people.
Yes. Yes, that's right.
So now they just need to build upon that.
Yeah, it would be really cool if they would just build in more libraries to be natively available in Ignition, like currently the Apache Math, which is again limited.
Right. Cool. Well, thank you for speaking with me, Ivana.
Thank you.
It was very enlightening. And I'll see you.
Thank you. See you.